Hi, my name is Ben. I'm a data scientist in medical device company. Throughout this course, you're going to learn how to manage data science projects. This is a project-based class that provides an example of the entire process from starting a project to reporting the results. Aggregated analysis of ClinicalTrials.gov, which is AACT post-GRE-SQL relational database, will be used as an example in this course. There will be 4 different sections: opening a project, data exploration, data analysis, and data visualization. In opening a project section, you're going to learn how to understand the needs of the stakeholders, communicating with stakeholders, how to elaborate on the cans and can'ts, and setting up the milestones. For the data exploration, we're going to understand the medical data, and we're going to understand the database API, and we're going to pre-process the medical data. In data analysis section, we are going to learn how to extract data with queries, and then how to filter our data, and then we're going to apply machine learning approach to get more insights of the data. In data visualization section, we're going to learn how to show the brief summary in Excel, how to visualize in Power BI, and how to report. In the next class, I'm going to talk about opening a project, and we're going to learn about the process of initiating a new project, important facts when communicating with stakeholders, how to prepare for the very first presentation, and then how to plan short-term goals step by step. Thank you.
Hi, my name is Ben. Today, I am going to talk about how we initiate a project in a medical company. To open a project, we need to understand the system in the company a little bit. We need to know what kind of manual workflows in clinical projects, different professional languages among collaborators, business aspect, and strategies on milestones. As a data scientist in a medical company, you need to focus on manual workflows in clinical projects. This is the top priority. Due to restrictions and long-term project environment, people tend to keep their workflow for 5 to 10 years without changing anything so that they don't need to risk anything from changes. However, there are tons of manual work to do. You'll definitely find something you can do about it. Here is an example. This is a simple example of a data management plan. A simple mistake can possibly cause a serious effect on patients. Normally, rules and policies for projects, so-called protocol, is very strict. And there are so many validation steps. Let's see. We review documents and design a database, collect data, track CRF, which means case report form, and people manually enter the data into the database most of cases. Since human can make mistakes all the times, there is a data validation step so that we can make sure 100% of data is accurate. And there is another step, discrepancy management. Even though data look okay, but some of them might not make sense theoretically. For example, if a patient visits the hospital, they sign an informed consent. Then, whenever they leave the hospital after surgery or payment for participation, discharge date is recorded. What if discharge year is 2005 and informed consent year is 2008? It does not make sense, right? There are so many data variables that have relationship, and it could cause an error due to many different reasons, such as mistakes from a person or the data itself is wrong. People read those manually. Then, people use medical coding to systemize the workflow. Thus, R, SQL, and Python are the common programming languages in this area. After all verification and validation process, we lock the database so that people cannot change the data anymore. Then, we create a report of the medical data. And of course, people make them manually. If this is just an annual report, one huge effort would be okay. But what if you need to create reports as many as the number of patients? Would you do all manually? You would not. But unfortunately, many people do them manually. There are lots of data to deal with, and if you create a report manually all the times, it is physically impossible. Normally, a report is requested to have a better insight of the data, so normally it should summarize huge amount of data together. There is another example. This is not even a summary. We only need to save all the data into database. If we don't set up an automated workflow, you'll have to spend more than 20 hours for the data entry and might not be able to finish in time. If you handle them manually, you may feel more confident they look perfect, but at the end, you will waste a huge amount of time. That's where we need to jump in and help. However, it does not mean that you can work on those problems. A couple of reasons. First of all, there is a protocol when there is a change, and this is not trivial. Unless what you're trying to do is very clear and would not be risky 100%, most of people will say, no, you cannot do this. Then you need to persuade them, make them understand what you're trying to do, but there is a language gap. I'm not talking about the language like English, Korean, Chinese, Greek. Many people do not have data scientist or computer science background, so it is very possible that they might not understand the impact of your work. Then they will not risk anything for small changes. There is a good example here. When you hear PD, outside clinical field would think of police department or program director. But it means protocol deviation in clinical world. On the other hand, if a data scientist explains his project and talk about XGBoost algorithm, people with clinical background might not understand, and they will not be confident to use your program because they cannot measure the risk. Risk assessment is crucial in clinical field, so you cannot do any projects unless possible risks are well elaborated in their words. Next, we need to understand the business need. Let me give an example. I can think of a cool project and it will be helpful for your team. You spend some time to make the program and share. People love it. They have an annual report and my program helps to automate the process. It could be able to save their time around, for example, 5 hours per year. Did you find anything strange? Will the company be happy with your work while they pay you? No, it is not. Even if it is helpful, your work should directly impact the business time-wise, money-wise, more efficiently. If you spend your time to make a program that people barely use, you're wasting your time, your company is wasting their money on your salary. You always need to think about how many people use it, how frequently, will it save companies money and time? This is a very essential truth that people easily miss. After you go through all those hardships, you will be able to start a project. But that is not enough. Many projects, especially exploratory projects, always open and close frequently. Unless your project looks useful and consistent, it can be closed at any times. You need to show visibilities and present feasible milestones so that your stakeholders are not discouraged and let them want to keep the project ongoing. For the first presentation, I would suggest to include this information. Regarding the topic, current state, potential state, which shows clear changes, benefit, end users, who is going to use it, risk, challenge, and technical requirements that you or end users may need some supports. Then you need to explain the milestones. Do not try to talk about what you cannot be sure to do. Only frauds will do that anyway. Of course, you have to explain the blueprints or the end product, what they can expect at the end, but you have to emphasize the achievable, this is important, achievable preliminary results in a short period of time. In a short term, they want to see the result so that they can be sure. You have to show you can do this by showing any visible results to proceed. Ask stakeholders what they need, clarify what is possible and impossible, confirm the form of outputs they want. It can be a PowerPoint slide, a Word document, a dashboard, or even a screenshot. Then, schedule a regular meeting to follow up to make sure everyone is on the same page. For example, if you drive a car, and if you turn 1 degree or 2 degree for 1 second, it would not make any differences for 1 second or 1 minute. However, if you drive for an hour or more than 1 hour, while 1 degree turned, you will completely off the road. Therefore, the regular meaning helps the alignment of the path to the result. Make sure to ask them about timeline and any deadlines. These are the key factors when you open a project. In the next session, I'm going to show actual Python code on a virtual project that I made. It will help you understand how we deal with data in real world.
Hi, my name is Ben. I'm a data scientist at a medical device company. In the biomedical field, opportunities for data scientists are relatively scarce. This is a hard truth. Biostatisticians and statistical programmers play pivotal roles in clinical and biomedical research, making it challenging for data scientists to gain recognition for their work. Therefore, it is crucial to understand our capabilities and identify meaningful projects to expand our impact. Today, I'll introduce ClinicalTrials.gov, a publicly accessible database of clinical research studies conducted worldwide. It is maintained by the U.S. National Library of Medicine, NLM, at the National Institutes of Health, NIH, and contains a wealth of information that companies can leverage. Let's go through it section by section. This is the main page. From the main page, we can see an overview of the study, including its title, intervention, condition, and sponsor. Crucial pieces of information. However, if we only needed this high-level data, we wouldn't be here, right? We aim to extract detailed information from each trial and combine it to gain broader insights into our chosen topic. For example, let's assume our company develops the COVID-19 vaccine remdesivir. We want to understand how many related trials are ongoing and predict our next steps. To do this, I'll use the CTTI database API, which allows us to extract information from ClinicalTrials.gov efficiently. Before extracting data, we need to understand the database structure. Most modern databases are relational databases, meaning they consist of multiple interconnected tables. This diagram illustrates the CTTI database structure. The study table serves as the central hub, while other smaller tables connect via specific columns. We'll be using multiple tables in our analysis.
Let's get back to ClinicalTrials.gov page. In the Study Overview tab, we see Conditions section. We only see COVID-19. Then what about conditions table in the database? This is the raw data of conditions table in the CTTI database. It currently contains almost 1 million of data rows. However, it has only condition name information and entity ID, which is unique ID of clinical trials. We need more information. This is sponsors tables in CTTI database. It contains entity ID, agency class, lead or collaborator, and the sponsor names. If we know the unique ID and CTID of the clinical trial, we can extract information of sponsors and conditions by using these two tables. But how? We merge them. Both dataset has different numbers of rows, meaning that both have different entity ID information. We inner join them to get only those entity ID which exist both in sponsors and conditions table. Also, each table has almost 1 million rows of data. If we merge multiple tables, it will be too huge and it'll start to cause issues. The merged dataset will take huge amount of spaces like 10 gigabytes. And if we transform the data in Power BI for visualization, it'll take a long time to load the data every time we update. Therefore, we need to understand what information we need from these data tables from relational database, and we need to wisely filter them and combine them to minimize the size of total data. For example, it is unlikely for us to need the entire data from each data table. Let me give an example of COVID-19 condition. We find only those entity ID with COVID-19 condition, and we generate the list of those unique entity ID. Then, we use the list to filter out unrelated entity ID from other data tables. Then, we will have filtered data tables from all data tables from CTTI database. Then, we can start from there with much smaller dataset, easier to handle, easier to understand. Here, this is the sample output, and I merged all the data tables together with some specific information. What I did here is that I use COVID-19 condition as the keyword, and then by using those related unique entity ID, and I filter out other tables based on these entity IDs. So when I merge them together, all those entity IDs will be related to COVID-19. So by doing this, I can have all those informations that I need, and I can get all those related entity IDs. Then what's next? We're going to use this information and we can make any type of reports. And typically, we can use them for Power BI visualization. It is easier to see and easy to make. And one thing I want to emphasize is that whenever you see those entity IDs, they look like duplicating, but actually it is not. Whenever you merge multiple data tables, this will always happen. And it is normal, so it is fine. Whenever you show this data in Power BI will handle this problem. I'll show this in the later steps. Now, I'd like to talk about the objective throughout this class. We want to get an insight of COVID-19 related clinical trials by using sponsor information, interventions, conditions, and other basic information. In the next session, I'm going to briefly explain how we want to extract this data using API. Thank you. Hi everyone, welcome back to Biomedical project class. Today, I'm going to talk about API. What is API? API stands for Application Programming Interface. It provides an interface for us to use the service. API is like a mystery box which saves all the rules and policies which help users to communicate with the backend system. We're going to use Python and let Python read the database via API. This is the main page of AACT, access to aggregate content of ClinicalTrials.gov. This page provides diverse information and API connection. First of all, it explains the database structure. This is the database schema, and it shows what kind of data tables are there and what variables exist. Here, study table is the main table. This contains the most number of columns, and therefore, it can give more insights of the data than other tables. Other tables are related to some of each columns, and that's the basic structure of this relational database. Depends on what kind of projects we're working on. We're going to use different data tables among those. However, there are so many data columns that we don't really know, and this can be an issue when you proceed. So, there are another type of data called metadata, meaning that it gives the information and descriptions of the column variables themselves. In this page, we can search tables named to see the variables of those tables. For example, there is a table named baseline counts, and it contains 7 variables. What if we want to understand the table named calculated values? Then we type the table name and click search. Now we can see what variables inside the table. However, this information might not be sufficient. What is the definition of each table? Do we really understand what each variable means? We can't. So now we need to look at data dictionary. It shows description of each table so that we can understand what kind of data we are looking at now. And this page also shows how to query those data. We use PostgreSQL, which is a free and open source relational database management system. By using PostgreSQL, we can query and extract data from the CDTI relational database. And this is an example how we can extract the data. We use NCTID from condition table, then we can get the data based on this information. But we're going to use Python So we will import a library which can let us use PostgreSQL inside Python. Then this shouldn't be an issue. We were talking about API at the very beginning of this session, and finally, we can test a little bit. We have data inside CTTI relational database, and we want to use PostgreSQL to query and extract the data. However, something is missing: a connection. There should be an API connection so that I can send query, and API will translate my request and find the data and send me back the response. Here, these are the information that we need for the connection. We have a conventional way to establish a connection, and I'm going to talk about it when we look at the Python code. In the next session, I'll show how we connect to the database using API and show how to prepare the data. Hi, welcome back. In the previous session, we learned about API. Now it is the time to use it. Before we move on, I would like to introduce some important Python library packages that we are going to use for the data pre-processing and extraction. There are two very basic libraries, Pandas and Numpy. If you don't know these two, you can barely do anything about data analysis. Let's have a look one by one. Pandas is a library for data analysis. We are familiar with data as a table. Each column represents variables, and each row represents individual data in general. To process this data table or data frame, Pandas has all required functions. It is very useful. Read and write files, create, modify, merge data frames, and most of the functions that SQL can do with data. You can accomplish the same goal as SQL. I believe most of you are already familiar with Pandas, so I won't go into too much detail. Another one is Numpy. It will be installed when you install Pandas actually. It has functions for scientific computing. When you need to deal with numeric data, you will use a lot. If it is text data, it has less roles to do, but still, it is very convenient to use this for string arrays. RE and OS are also very important libraries that I always import for most of my functions. First, let's look at RE. RE represents regex, meaning regular expression. Some of you might not be familiar with regular expression. Regular expression is a sequence of symbols and characters expressing a string or pattern to be searched for within a longer piece of text. It is extremely useful when you try to search a pattern of strings, and therefore many programming languages use regular expression. How we apply the regular expression to different programming languages is somewhat different, but the basic rule is always the same. It is better to actually look at how it looks rather than looking at this weird text. There are some simple examples. There are three text string arrays. RESUB means subs function, which searches a string pattern and substitutes. The where string starts with R is the regular expression. Inside quote is the string itself, and the single character R outside quote defines the string as regular expression. Caret symbol is the expression to find any starting patterns. Caret they means find a string start with they. Dot asterisk means any characters, any length in between they and I have. If we run resub function there with text1, it'll give us I had a chance. Text2 is the same as well. However, text3 will give us they said I have a chance, which is the same. Why is that? Because it is case sensitive. It does not start with capital T, so resub cannot find the regular expression pattern so that it would not change anything in text3 and return. It failed to find the pattern and failed to substitute. Regular expression is extremely useful and at the same time difficult to use. But if you know only that expression above, it can solve most of pattern search problems. Remember this. There are many other useful syntax for the regular expression, and if you want to learn more about it, go to search regex cheat sheet in Google, then you can find more information. Next one is OS library. It contains operating system related functions. When you have input files and output files, we must specify where to save, where to load those files. Every operation system has slightly different directory structures and paths, and this library lets us easily handle them without any issues. The one I love the most is OS path join. Whenever we copy the directory path in Windows, it looks like C / download Python / something like that, with / in general. And it can be / also. So Windows is less sensitive with the /. However, it might not work in other systems. Some operation system allows only /, and sometimes we need to use double /. To avoid this operation system compatibility issue, when I program, I use this. Let's assume that my current folder is the working directory of the program. If I want to save files in data folder inside the working directory, I can use OS path join data, and it can adapt to operation system automatically. It can be current folder / data or current folder / data, depends on the operating system. If collaborators use different operating systems, you can be able to use the same code in his computer. This will be a very useful tip when you work with many people. And of course, there are many other functions to handle files and directories, so you should be familiar with this library as well. Those 4 libraries are my personal must libraries to keep all the times for any course. Keep in mind. Now, let's look at the actual code that I programmed for the ClinicalTrials.gov project. This is my code. I have imported more libraries there. Datetime is used for date and time formatting for strings. Pickle library is for object serialization, and I'll explain when we use it down there. PsychoPG2 is a PostgreSQL database adapter, which we need to connect to the SysTI database. Warning, it is only to hide warning sign, which we don't really need. Sometimes we face some warnings which are not really important to run the program, and it wouldn't cause any errors, but still we see the warning sign, mainly due to some issues whenever there is a version differences or some minor issues. So if you don't want to see those unnecessary warnings that we don't really need to know, then you run this code. Otherwise, you can remove these. Okay, so here my code starts. First, I define input and output directories. Then, I load the authentication token I previously saved for CTTI login. Then, what is a token? When working on a project, we often share our code via version control systems, like GitHub. Naturally, we don't want to expose our login credentials to team members. Instead, we serialize the login information and save it as a pickle file. That's why we need a pickle library. Now, let's look at how we create a token. This is the file that generates the pickle file. What it does is it generates a pickle file containing my authentication token. We just put ID and password and then file name and run it. Then it is going to generate the pickle file here. Then, after you run it, remove your sensitive credentials from the script before saving or uploading it to version control system. However, keep in mind that this approach does not fully protect your credentials from someone running the code. So, I highly recommend using a temporary or dedicated project-specific password rather than your personal one. Now, let's return to our main script. First, we connect to the CTTI database using our authentication token. Then, we extract data from the tables of interest by writing queries and sending them through the API connection that we learned last time. For this analysis, we first extract conditions, interventions, studies, and sponsors tables. This is the size of the conditions table, and then we are going to filter this out so that we wouldn't have too big data. I filter studies using the keyword COVID and store the corresponding entity IDs for further data extraction. Using these entity ID lists, I pull relevant data from other tables and merge them to compile the information we need. So by using this entity ID list, we extract intervention, studies, sponsors, and then we merge all together. Now, let's look at details how we create and merge each table. First, we filter the condition table with the keyword COVID. Then, we don't need to worry about unnecessarily huge dataset. We have 900,000 rows at the beginning, and then it becomes 7,000 only. Since the first dataset condition will be filtered, and we are going to use entity ID from here, which is IDS, other data table size should be fine. Then, we extract data from intervention table. Intervention in clinical trials means that any action or procedure taken to prevent, treat, or improve a health condition encompassing medical, social, behavioral, or environmental approaches. This could be device, medicine, or even medical treatment. Then, let's think about this. All the COVID-19 related clinical trials might have different types of researches and different interventions. Our company might want to focus on our product-related trials. Let's say our company is producing medicine, remdesivir. And actually, there is another name for remdesivir, veklury. So our keyword should be remdesivir and veklury. So we put the keyword here. We still want to filter unnecessary topics from internal table. So by putting this keyword, we can minimize the size of the data table, and we remove unnecessary clinical trials. Then we extract studies and sponsors table and merge all together. Let's see how our data look like. You can see one entity ID has multiple rows. This is actually normal when you merge data. Each row contains different combinations of information, and it'll be adjusted in Power BI, so it is okay. If we actually want only one entity ID per row, we need to clean up the data first. There is one typical issue while merging multiple tables. We have column name, name X, and name Y. Each table had name as column name, and it becomes name X and name Y when we merge them together. To avoid this, we have to rename column names when we extract the data table. Name X here should be intervention, and name Y should be sponsors. Finally, we have a merged data frame, and we are going to discuss how we want to use this data in the next session.